So, good evening, everyone. So, today's webinar will be on the concept of data engineering. So, before we start with the webinar today, let me give you a introduction about myself. So, I have been into training and consulting for more than 9+ years now. I have conducted several trainings on the cloud platforms, including the Google Cloud Platform, as well as the Microsoft Azure Cloud Platform. And my basic specialization is from machine learning, artificial intelligence, and data engineering. Some of the certifications that I hold are a Google Cloud Professional Data Engineer, Database Engineer, and Microsoft Azure Data Scientist. So this is about me. Coming to the agenda for the session. So initially we will start with what is data engineering. Okay, what do we mean by the concepts of data engineering, and then what are the different job roles that are there in this particular data domain, because data engineering is a very broad word. Okay, so there are too many job roles that can be done in the data engineering. Understand why data engineering is required for any organizations, and in today's world how many of the organizations employ the data engineering to reach their customers, and what are the important concepts on data engineering, what kind of tools are used, what kind of technologies are present that are required for a data engineer to be learned. Okay, and how do they employ all these tools to perform data engineering to solve the business problems of an organization. And then towards the end, we will see what are the different career opportunities that are there, in what all domains the data engineering can be applicable. Okay. And then we will see how a person who is very much new to data engineering or starting from the scratch, how can he end up being a data engineer. And then we will conclude the session with any Q&A that you might have. So this will be the agenda for the today's session. So let us start by understanding what do we mean by data engineering and what exactly its definition. So data engineering is a very broad field. The discipline of the data engineering involves designing, first one, building, and managing, the third one. Design, build, and manage systems that transform and process large volumes of data. Large volumes of data is something that you need to keep in mind. So whenever we say large volumes of data, we are talking about data that you will be processing at terabytes or petabytes. So you will design, build, and manage systems that are capable of transforming and processing large volumes of data into reliable and usable formats. For what? For performing further analysis on that. That is to derive insights from the data. What is the pattern that you can see in the data, and what is the insight that you will draw from that particular data. And whatever the analysis that you have done and the insights that you have derived, report that to the stakeholders, that is for the management of the organization. And from that particular reporting, they can make the decisions so that whatever the data is trying to tell us, we understand that and we take suitable decisions for their products or for the services that the organization is offering, so that the data engineering or the system that we have built will be more beneficial for the customers or the users of the organization. So this is what we mean by data engineering. Design, build, and maintain the systems where the responsibility of the system is to transform and process large volumes of data. So some of the examples of data engineering being employed at some of the notable organizations, such as Netflix, So Netflix uses data engineering pipelines that is there, or the systems that is there, to recommend movies and TV shows to its users. So whatever the recommendations that you're getting on your Netflix app or any other video playing app that is there, okay, based on your previous videos that you have watched or the TV shows that you have watched, okay, and based on your preferences that you have set in the apps, okay, and how users across the globe who are having similar preferences as yours, what kind of videos they are watching. So all these things are taken into account, and that is when the recommendation gets that is when the recommendation is put out to the user. Second one, Amazon uses the data engineering concepts to track its inventory and shipping. So what all products are there in the inventory, what is the customer demand, what are the kind of products that the users are preferring, and for a given season or in a given period of the year, what are the products that might get sold, okay, so that they can stock their inventory. And then every time an order has been placed, how do we ensure that this particular order from the warehouse is shipped to the customer, right? So there are different phases of the shipping. So how that is tracked and maintained, for all those information that is there, they are using the data engineering concepts. Third example, Uber uses the data engineering concepts to track the riders and the drivers. So for example, in a given point of the time in a day, say for example at 10 a.m., where are the maximum requests coming from which particular geographical location, how many requests are coming, so that they can place the drivers or more number of cabs in that particular location. So for all these business problems that we have stated for Netflix, Amazon, and Uber, data engineering is the backbone. So this is what enables them to run their products or services successfully. Now we will see what is the importance of data engineering, irrespective of the domain in which the organization is working. So in general, the data engineering will be helpful for improved decision making. So as we have previously discussed that, right? So data engineering will help us transform data so that we can perform analysis. So if you can perform good analysis and try to identify the patterns in the data, so those patterns in the data will help you take improved decisions. So a simple example is that whenever these big billion days or these kind of events are happening, so which are the most likely products that are to be sold, correct? So what is the amount of discount that you should put on each of the product? How do you decide that, correct? So to answer these kind of questions or to make these kind of decisions, data engineering is absolutely required at the back end. So how do they make these kind of decisions? So they identify the trends, how the products have been purchased, how frequently they are purchased, what is, they have to analyze the demand in the market, right? Understand the customer behavior. So for which kind of product, if you give more discount or even if you give less discount, the product is getting sold. You have to understand that before you fix a discount, right? On big billion days or any of the Amazon Prime sales, these kind of events are happening, correct? So, and then make predictions that if you set this particular value for this particular product, that is when it will get sold, because more the sales the e-commerce company does, more the profit he gets. So for this, you will require accurate and reliable data to be present in your system to identify the trends, customer behavior, and to make predictions. So generating this accurate and reliable data will help in improved decision making. So to get this accurate and reliable data, you need to perform data engineering. Second importance, increased efficiency. So because of implementing a data engineering system that is there, you can increase the efficiency of the business by automating the tasks and the processes. such as whatever the shipping information that is there, that can be automated so that the user gets a notification, or there is a new product that that has been launched, so you can automate sending notifications to user, or the user is interested in some particular product and he has in wish list, right? So if the price goes down, or if the new product has launched, for sending these kind of notifications, right? So you need data engineering at the backend so that the efficiency of the service that you are having will improve. Or whenever a new movie comes, you need to recommend that to the appropriate users. So to increase this kind of efficiency, you need data engineering at the backend. Third one, reduced costs. So by employing the data engineering tools and techniques that are there, so obviously the human resource will be reduced, correct? So you will be using most of the automated tools, and the data pipeline or the system that you have built, that entire thing can be automated to work periodically or to work 24/7. So in this particular way, you can help the organization reduce the cost. Fourth one, enhanced customer service. So because of the improved decision making and the efficiency with which you are making the decision, obviously the customer service will in turn increase, correct? So by providing good recommendations and by showcasing new products and the variety of the products that you have, obviously you will be tempting the customer to buy that particular new product, or by providing small amount of discount, you will be motivating the customer to buy that particular product, correct? So that is how the enhanced service come into picture, which with respect to the three examples that we have seen in the previous slide. So these are some of the importances of having a data engineering in an organization. Now coming to the roles in data engineering. So the most frequently associated word with data engineering is data engineer. But apart from that, you have many roles that fit into the entire discipline of data engineering. First one, data architect. Second one, data engineer. Third one, data analyst. And fourth one, data scientist. So in huge organizations such as Netflix or Amazon that we have discussed, right? So there will be a team of data architects, there will be a team of data engineers, there will be a team of data analysts, and there will be a team of data scientists who fall under the discipline of data engineering. But coming to a mid-level organization, the data architect and data engineer might have only one team. Data analyst and data scientist put together might have one team, correct? And coming to much smaller organizations or startups or these kind of scenario, there could be only one person who will perform all the four tasks. So with that particular distinction in mind, so we will associate the job roles that we have with the kind of the work they do. So it could be several teams, or it could be one person who will do all these things, depending on the size of the organization. So all these four job roles fall under the discipline of data engineering. First one in that is the data architect. So generally an organization will have a business problem that they need to solve. So they are facing a struggle in some particular scenario. For example, if you take the banking domain, say for example, the bank might be finding it difficult to decide whether to approve a loan or not for a given customer. And given his credentials, what is the loan amount that he's seeking for, and what is his salary, and so on. So we have to take many factors into consideration before they approve a loan, right? What is his CIBIL score, or those kinds of things. So this is an example of a business problem that the organization will come up with. So the job of the data architect is to take this particular business problem, convert it into a technical problem, and then for that particular technical problem, devise an architecture okay, of data pipeline, which will help the organization solve that particular business problem. So to build this architecture of a data pipeline, which will perform the transformations and the process on the data, he will discuss with the stakeholders or the management in the organization, understand their business need, that is their business problem, and accurately convert it into a technical problem and provide the end-to-end architecture of the solution. So generally, data architect will prepare an end-to-end architecture of the data pipeline by understanding the business needs. Now coming to data engineer. So data engineer is the person who is actually responsible for building the data pipeline that was architected. So building in the sense implementing it using the different technologies and the tools. And once the pipeline has been built and then deployed, he has to regularly maintain that particular pipeline, because on an average, say 1,000 customers are visiting your website. On sales, or when there is a hike in the demand, the 1,000 customers or users might increase to 5,000 or 10,000 within a short span of time. So your data engineer will always be maintaining and monitoring the pipeline so that these kind of huge amount of traffics can be absorbed, and then the website still doesn't go down or your app doesn't get crashed with server errors, right? So that is where maintaining comes into picture. Implementing the pipeline and monitoring and maintaining the pipeline is the job of the data engineer. So basically, what does he do? He collects the data, he stores the data in some particular storage, and then he will process the data. So all the three steps that is actually present in the data pipeline. So data pipeline will contain only these things, right? Collecting the data, storing it in some place, and then processing it. So implementing the pipeline means implementing all these sub blocks. That is the job of the data engineer. Third one, data analyst. So whatever the process data that is there, so he will further clean the data, and then he will further transform the data which is suitable for analysis, and then he will analyze the data. So three things the data analyst will do. The process data that is already there, he will take that, he will further clean it if required, and then he will transform the data so that it is suitable for analysis, and then he will also analyze the data. So analyzing the data will lead you to deriving the insights. Correct? So such as, say, in the month of June and July, that is when the rainy season starts in a particular region. So for people in that particular region, they will start recommending, say, umbrellas, raincoats, or these kind of products, right? So that is how the insights are derived. And the insights that they have derived, they will in turn share it with the stakeholders or the management of the organization. See, this is what we have seen. Or in the previous year, in the month of the June, so and so product were highest sold. So this, in this particular category, the sales were the highest, and in this particular category, the sales were the least. So giving these kind of insights to the stakeholders is the job of the data analyst. And the last one, data scientist. So he is also responsible for extracting the insights from the data after the analysis. So this amount of job is common for both data analyst and data scientist. And once he understands what is the insights coming from the data, he will use techniques like statistical analysis, machine learning, and natural language processing, correct, to derive those particular insights, or after deriving the insights, to automate the tasks that we have previously seen. Automation is one of the importance of having the data, building a data pipeline. So to automate things, he will be able to use this machine learning and natural language processing concepts, and then build an automated solution using the machine learning products. So these are the four job roles in data engineering. I see that there are a couple of questions. Yeah, no problem. We will take this particular queries to the end of the session. Okay. Now coming to the key concepts in data engineering. So what do we mean by building a data pipeline? So the data pipeline is one that has mainly 4 components. First one is data ingestion. Second one is data storing. Third one, to transform the data and analyze the data. And fourth one, to visualize the data. So data ingestion includes all the tools and technologies that you will need for collecting and importing the data into the system or into the data pipeline. So to collect all the data and then to import the data into the system is what data ingestion does. Data storage, for all the data that has been ingested into the system, which is the appropriate storage option and where to store which kind of data. That is what the decision needs to be made while selecting the data storage in the data pipeline. And then build data lakes, data warehouses, and data marts. Third step is the data transformation. So in this particular data transformation, whatever the data that has been ingested and stored, we will clean that particular data, structure the data into appropriate format, and then transform the raw data into the usable format. So sometimes the data, whatever that you're getting, might be text data and you would want to quantify that, right? Or you will also having some of the data which is continuous data. And then you want to group them into separate categories so that you can analyze. So these are some of the examples of the transformations. And fourth one is the data analysis. So once the data has been transformed and into the usable format, so you will apply the analytical techniques to derive the insights from the data, which will answer the business problems. So those insights, whatever you have derived, you will be visualizing it in a dashboard. So data visualization is nothing but the representation of the insights. So these are the 4 main blocks that is there in data engineering. So now we will see each of this particular blocks in detail. So before that, we will see an example of what all components that we have discussed in the data pipeline. So in this particular example, so we have 2 data sources, where first data source is sending information from the servers stored in a remote location. And in the second one, we have IoT devices, large number of IoT devices that are sending information to our system. So the data sources are actually outside our data pipeline, and our data pipeline starts from this particular block. So whatever the data that is coming, how do we ingest these kind of data? What tools are to be used, and what is the important characteristics of that data? How do we ingest them into the system, and then how do we store it? And once the data is stored, what kind of transformation should be applied? What kind of transformation should be applied, and which tool should be used for those kind of transformations? And whatever the cleaned data or the processed data that we have, where do we store this particular processed data so that it is quickly available for us for analysis or for performing training the machine learning models? So these are the important steps that we have discussed in the data pipeline. So now coming to the tools that would be used for data ingestion. So before we decide on the tool that should be used for data ingestion, we need to know what is the characteristic of the data. So the data can be of 2 types. First one is the stream data. Second one is the batch data. So stream data is the one that is generated continuously in real time. So you keep getting the data every few milliseconds or within few seconds. So any data that is coming out continuously in real time is categorized as stream data. And any data that is collected and processed in batches is called as the batch data. So this particular batch data is the one that will come out periodically, and this will be huge amount of data. And whatever the stream data that you are getting continuously in real time, so this will actually be small amounts of data that you will be receiving. And example of stream data includes, say, a financial transaction that is such as a credit card transaction that has happened, or a UPI payment that has happened, and so on. Sensor data, any sensor data coming from an IoT device, say, which is measuring temperature, humidity, pressure, altitude, or so on. And then the social media posts, the tweets or any of the LinkedIn posts which are getting uploaded, right? So all these are examples of stream data, which will be coming continuously in real time. And with respect to batch data, some of the examples include the customer transactions that have happened over a day or over few hours. So every 2-3 hours, all the transactions that have been occurred from the customer, if we are ingesting that into the data pipeline, then that is an example of batch data. Or medical records that have been scanned over a period of time. So daily, once all the medical records get uploaded, that is an example of batch data. And similarly, the scientific data coming from any of the sensors or any of the other servers that are present, which get periodically uploaded, those are the examples of batch data. So generally, batch data is ingested into the system either directly from the system, or there are something called as the migration tools that can be used. So when we say directly from the system, such as file upload, so these are the techniques that are used for ingesting batch data. And specifically for stream data, so these are some of the examples of the tools that can be used. So as far as examples are concerned, so I will give you examples of the open source tools that are used, and I will also give you examples from the 3 major clouds that are there: Microsoft Azure, AWS, and the Google Cloud Platform. So this is how the examples would be structured. So if somebody wants to implement the data pipeline using the open source tool, which particular tool should be used at which particular step, that also you will know. And if you are architecting the data engineering pipeline using the concepts of the cloud, then in which particular cloud, which service should be used. So with respect to the open source, some of the example is Apache Kafka. And with respect to Google Cloud Platform, you have a service called PubSub. And with respect to AWS, it is AWS Kinesis. And with respect to Microsoft Azure, it is the service bus messaging. So these are some of the tools that can be used specifically for ingesting the stream data. For batch data, generally we will go with a file upload or a migration tool. So the main important characteristic between batch and streaming data. So stream data is the one that will be coming continuously in real time. Batch data is the one that will come periodically, and processing of this particular batch data also will take lot of time. And processing of the stream data has to happen in real time, and live results have to be produced. So stream data are the ones which will be small in size, and hence they take less processing time. Now coming to the data storage part. So before we understand the services or the tools that can be used for data storage, we will understand the three important terminologies. First one is data lake. So data lake is a place where you will be having large amount of raw and unprocessed data. So this is the word that gets associated with the data lake, raw and unprocessed data. So all the data in its native form will get stored in a place, and that particular place is called as a data lake. And any data lake that you are building should have support for structured data, semi-structured data, and unstructured data. So structured data is the one that is coming in the form of tables, CSV files, or the database dumps, your SQL dumps. Semi-structured data are the ones where you can expect data in the form of a JSON format, XML, or YAML files. And unstructured data is the one which will comprise of audio, video, and your natural language processing text. So data lake should have support for storing any type of data that is coming in. Second one is the data warehouse. So data warehouse acts as a central repository which will mainly store the structured data in an organized manner. So all the data that is there is structured so that you can have multiple tables. You have star schema, snowflake schema, and so on, right? So you will be employing one of those schemas to store your structured data in an organized fashion, so that for whatever the analytics that you are doing or for whatever the reports that you are generating, you can easily run your SQL queries and then pull out the relevant data. And third one is a data mart. So data mart is the subset of the data warehouse, which is tailored for specific business function or for a department or for a user group. So if you take the example of a e-commerce website, all the data that is coming, right? So new product information, images of the product, customer transactions, all that particular information will be dumped into data lake, and the sales information, the product information, these things will be suitably structured so that if you ask a question in the month of June, which is the product that was highest sold, from that particular table, a SQL query will be able to answer your question. So storing the data in that kind of a structured format will help you build the data warehouse. And finally, segregating the information specific to users or segregating the information specific to a category of the product that you have, or segregating the data based on the sales and the inventory data, so on, is what is called as a data mart. Now we will see the difference between data lake, data warehouse, and a data mart. All the data that is coming from the source, which is the raw data, will sit in a data lake, and from whatever the data that is present in the data lake, we apply some kind of transformations, and then we create a data warehouse so that the data is readily available for usage. And from the data that is present in the data warehouse, we divide them, and we can also use some transformations to create data mart, which are specific for a business unit in the organization or for a use case. So this is the difference between the data lake, data warehouse, and a data mart. So now we will see some of the tools that are used for the data lake. So generally, data lake is a place where you can have huge amount of data. So some of the open source technologies include Hadoop distributed file system, HDFS in short. You can also use Apache Cassandra, which is a columnar database, which will act as a data lake. And also you have the Snowflake data lake solution where you can build the data lakes. And coming to the clouds, so you have Google Cloud Storage, which is the data lake in the Google Cloud, and you have Amazon S3 in AWS, and you have Azure Data Lake Storage in the Microsoft Azure. So these are some of the examples of the tools and technologies that you should be aware for building the data lake. So previously we were discussing the second block of our data pipeline, which is the data storage. And then we have discussed the tools that are required for the data lake, which stores the raw data. So now moving further, for the tools that are used for the data warehouses, Hive, again, which is part of the Hadoop file system or the Hadoop ecosystem that is there. Snowflake and Teradata. So these are the three mainly used data warehouses from the open source technologies. And then coming to the cloud platforms. So you have Google BigQuery, Amazon Redshift, and Azure Synapse to build your data warehouses on the cloud platforms. So these are some of the tools for building your database. And finally, coming to the data mart. So data mart, as previously discussed, it is only a subset of the data warehouse which is used for a specific business unit or for a specific use case. So they will generally contain small amount of data which will go into further in-depth analysis or which will go into the machine learning model training. So since the data size is less compared to the overall data that is present in the data warehouse, so for data mart, we can go with any of the standard RDBMS solutions that we have. Okay, so any of the SQL databases that you can use as a data mart. You can also use NoSQL databases such as MongoDB and Apache HBase, again, which is a Hadoop product, and an Elasticsearch. So this is mainly for the document databases, which will store data in the form of the key value pairs. Okay, or in the form of the JSON. And then under NoSQL, you have another category which is called as an in-memory database. So this is used as a cache database for frequently queried data. Or say, for example, whenever you have an online gaming, right? So how does the leaderboard of all the players be maintained in real time? So for that, in-memory databases are used, such as Redis and Memcached. And also the third category of the NoSQL database is the graph databases, and a popular example of that is Neo4j, which is also better suited for training the machine learning models. So in case of graph database, the data that we store is in the form of nodes and vertices, or nodes and edges we call. So these kind of data is more suitable in case of the telecom domain. Okay, so that is where the graph databases come into picture. Once the data storage part is done, after ingesting, now we know for what kind of data, which databases should be used, or what kind of tools we should use. So now coming to the third block, that is the processing block itself. So for data processing pipelines, we have three terminologies that we need to understand. First one is extract and load. Second one, extract, load, and transform, which is called as ELT in short. Third one, ETL, extract, transform, and load. These are the three techniques that are used for processing the data in the data pipeline. So in case of extract and load, we directly take the data in the simplest form, or the raw data, that whatever we have in our data lake or from the data sources, and directly store it in our target system, where the target system can again be a data lake or a data warehouse. Most of the times it is a data warehouse. So EL kind of a data processing pipeline is used whenever you are sure that the data, whatever that you are getting, is clean data and it is in the exact format in which you are expecting. So if you are expecting an integer, you will always get an integer. It's not that you will get a float or a string kind of a data. So the format of the data will always match, and it is always clean data. You will not get null values or missing values kind of a thing. So in that particular scenario, we will go with extract and load. Second technique, extract, load, and then transform. So in this particular case, we will get the data first, ingest it, then store it, and then after storing it, we will transform it. So in this particular kind of ELT pipelines, so you can ingest the data from any of the tools that you have used, store it in a target system data lake, and then transform the data that is present in the data lake and then store it in a further target system, which can be a data warehouse, so that your raw data is always present in the data lake and only your transform data, which is used for analysis, will sit in the data warehouse. Third technique is the ETL process. So where you will ingest the data, immediately transform the data, and then you will store the data. So in this particular scenario, your system will always contain your processed or the transformed data. You will not be able to access the raw data. So in this particular scenario, so whenever there is no need for the raw data and you only want your transformed data to be available in the system, that is when you can go with ETL. So for this, the various source systems from which the data can come can be databases, files, or the APIs. And then you perform the transformations or any of the cleaning operations that is there, that is check for the missing values, or convert an integer into a string into an integer, or any kind of transformation that you are doing, so that the data is consistent with your target system, that is your data warehouse. And finally, you will store the transformed data in your data warehouse or in your data mart. So these are the three types of data pipelines that we can build. So just an example here for mainly between ETL and ELT, because EL is a scenario where we rarely come across. So here we extract the data, that is ingest the data, transform the data, and then load the data into the target system, which is your data warehouse. So this is the source. And for processing, we will discuss in the subsequent slides the tools that are used for transforming the data. And in case of ELT, so you will get the data from the source, you will extract it, store it in a data lake. The target system here is a data lake, and then you transform the data, and the processed data can sit in a data warehouse. So this is how ELT and ETL pipelines are used in conjunction with your storage models. Now coming to the data processing pipelines itself. So you have Apache Spark, where you will be building your data processing pipeline using the coding languages such as Java, Python, Scala, or Go, which is again a product of the Hadoop ecosystem. Okay. Then you have Informatica Power Center, where you will have a GUI support for building your data processing pipeline. You also have Oracle Data Integrator. You have Databricks, which is nothing but the managed version of your Apache Spark. Okay. So these are some of the open source technologies that you can use. And then coming to the cloud platform, you have Cloud Data Flow, which is actually built on an open source technology called Apache Beam. Next, you have AWS Glue, and you have Azure Stream Analytics. So these are the three tools that you can use for building the ETL or the ELT pipelines. And finally, you have one more cloud product, which is actually called Alitrix. So this is also a GUI based data processing tool, where you can build your data pipeline by using the GUI components, so that you will be able to visualize the data. So depending on the coding preference or the GUI capabilities, you can choose the appropriate product. And then the sub part of the third block is transformation and analytics. So we have previously seen the transformation. Now we will see the analytics. So the transformations always contain smaller operations, such as combining two columns or splitting a column into multiple columns. Say, for example, if you are getting timestamp, splitting that into day, month, year, hour, minute, second. So these kind of operations, and then checking for string values in a particular column where an integer or a floating point should come. So doing these kind of operations is categorized as transformations. Now coming to the analytics. So analytics itself includes examining and interpreting the transformed data that we have so that we can derive meaningful insights from the data or identify the patterns in the data that is there and then make informed decisions. So analysis means examining and interpreting the data to derive insights, patterns, and in turn take decisions from that. So there are three kinds of analytics that are generally performed. First one is the descriptive analysis, where this particular descriptive analysis will focus on understanding the historical data and then summarizing it in a meaningful way. We will see an example so that it becomes clear in the subsequent slide. So we try to describe the data. What is the data trying to tell us? If we are going to describe it, then that is descriptive analytics in short. Second one is the diagnostic analytics. In this particular scenario, we will try to identify for anomalies in the data or events which have caused problems in the data. So if you are trying to look for an anomaly or a problem in your data, then it is called diagnostic analytics. Third one is the predictive analytics, where you are using the machine learning models which will train on the historical data, and then you are making predictions or forecast the future events or the outcomes. So if you are predicting something for the future, then it is predictive analytics. So some of the tools that you can use to perform the data analytics are the Python language, R, SQL, and then Apache Spark, previously discussed. So it supports Java, Python equivalent, that is the PySpark, Scala, and also Go. And apart from this, you also have a GUI tool where you can perform the analytics, which is an open source version. It is called CDAP. So this is the GUI part. For people who are not comfortable with the coding, they can use the tools like CDAP as well as the data prep that is there. So data prep is also a GUI tool which can be used for data analytics. So data prep actually is a product from a third party but integrated into the Google Cloud as well. Okay. Now coming to the cloud platforms. So you will have Dataproc and BigQuery, where you can perform data analytics in the Google Cloud platform. With respect to AWS, you have Glue Data Brew, and you also have Amazon Redshift, which is the equivalent of the BigQuery. And coming to the Azure, you have Synapse Analytics and HD Insights, where you can perform your data analytical operations. Now the last block, that is the visualization. So whether you do descriptive analysis or diagnostic analysis or the predictive analysis, you will have to represent the output of your analysis in a graphical representation format so that it becomes easy for the stakeholders or the management to understand. So data visualization is the last block of our data engineering pipeline, which will help us build charts, graphs, and maps. Putting it all together is called as a dashboard. So this particular dashboard will help us understand the patterns in the data, what is the trend that it is following, and any relationships that is present within the variables of our data. So to build good dashboards and visualizations, we can make use of Tableau or Python libraries such as Matplotlib, Seaborn, Plotly, and you have many more. And coming to the cloud solutions, on Google Cloud, you have a Looker Studio, and on AWS, you have QuickSight, and on Microsoft, you have the Power BI tool. So now we will see an example of a descriptive analytics and its visualization. So if we assume that this is the data that we will be analyzing from this particular tabular data that is already there, if we are able to plot these kind of charts, correct? So where you will get to know that from the data set, highest number of people are having white as their favorite color, and among the total number of people that we had, male respondents were very high compared to the female respondents. So these are some of the insights that you can draw by performing analysis and visualization. So which is the favorite color of the many people that we have surveyed here? It is white, around 24%. So this is how the descriptive analytics is done, where you try to describe that data or the pattern or the trend that is present within the data. Now coming to the diagnostic analytics, if you are asking these kind of questions, why did so many umbrellas sell in this particular month? And then you try to identify a reason where there was a change in the weather and you had lot of rain unexpectedly. That is why most of the umbrellas were in demand. Okay, then that is a diagnostic analytics. So generally there is a particular period of the month where it will rain. So, but if you see an unprecedented surge in the demand for the products, then you go ahead and perform diagnostic analysis, where this is an anomaly or an event that has occurred which you have not anticipated. So that is diagnostic analytics. And third one is the predictive analytics. So to perform the predictive analytics, so we make use of the machine learning model. So we train the machine learning model on the historical data, and then we make a predictions for the future point in time. So some of the examples are Netflix uses the machine learning models to recommend your movies and TV shows. Uber uses machine learning models to improve the ride hailing service. So the machine learning model will try to predict the geographical location from where the maximum requests can come for a given point in time on a given day in a month. Similarly, Walmart makes use of machine learning to ensure that it has the right amount of products in the right stores at the right time, so that they can cater to the demand of the customers or the users. So it is trying to predict the forecast for the subsequent months from the historical data. So training the machine learning model and then using it for the customer service is an example of the predictive analytics. How do we perform machine learning? So we can make use of the scikit-learn library, TensorFlow library, PyTorch, or many of the other deep learning libraries that are available, open source. And from the Spark or the Hadoop ecosystem, you have the Spark MLlib, which can be used for training the machine learning models in a distributed fashion. So these are the open source solutions. Coming to the cloud solutions, you have Vertex AI and BigQuery in the Google Cloud Platform, where you will be using Python coding to train the model in Vertex AI, and you will be using the SQL commands to train the machine learning model in BigQuery. In AWS, you have SageMaker, and in Azure, you have Azure Machine Learning Studio. So in all the three clouds, you will have an option for no-code machine learning model training, where you need not to use any of the coding languages, and still you can train the models, which falls under a category called AutoML. So automated ML is one particular service that is offered in the cloud. So now, while we are preparing and deploying or architecting the data pipeline end to end, what are some of the things that we have to keep in mind while we are implementing the 4 blocks that we have discussed? That is ingest, storage, process, analyze, and visualize. So one thing that we have to always keep in mind is the data quality is good. So data quality refers to the accuracy of your data that you have collected, because if the data that you have collected is inaccurate, then your predictions will go wrong, your insights will go wrong, and the service will fall down. The completeness of the data. So if there are too many missing values and if it is incomplete data, you cannot make predictions or derive insights out of that, you will go wrong. And the consistency of the data. So the format in which the data is coming, that is what we call as the consistency. So at each and every block of your data pipeline, you have to ensure that the data is having high quality. So to ensure the data quality with respect to accuracy, completeness, and consistency, you do something called as data profiling to identify the quality of the data. And if it is bad, you do data cleaning to ensure that it is accurate, complete, and consistent. And then you validate your data cleaning process so that your insights do not go wrong. So while building the data pipeline, you have to ensure that the quality of the data is maintained. And second thing important in data engineering is data governance. So data governance relates to the set of policies and procedures that are laid down in a given geographical region, and you have to comply with the law of that particular land. So what does data governance tell you is how the data should be encrypted and who should have access to which data. So the sales team should not have access to the inventory data or vice versa. Data retention policies for how long the data should be retained in a particular storage service or in your ingestion service or in your transformation service. And when should the data be automatically deleted or disposed from your system. So all these are mainly to protect the privacy of the users as well. So data governance has to deal with the law of the land, regulations that is present, that could be from the client side or from the organization side. It also has to ensure that the requirements of the client are met. And then it has to follow the standard procedures or any of the rules that are laid down in the standardization process. And it also has to be in sync with the policies and the data transparency rules that are present. So all these things will come under data governance. So while you are architecting or implementing data pipeline, you have to ensure that all these requirements are fulfilled. Next comes data security and privacy. So we have to ensure that the information of a particular customer, which is private, is not disclosed or it is not used in the analytical purposes. It should not be used in analysis. So for that, you will have to ensure that the regulations that are put down by the government is being followed. Some of the examples are the GDPR and CCPA. So to ensure that you fall in line with these regulations and have data security and privacy, you have some of the tools in the cloud. In GCP, you have data loss prevention, and in AWS, you have Maze, and in Azure, you have information protection. So these tools will help you identify the sensitive data and then desensitize them. Say, for example, you have the credit card information. So generally, if you are making payment, you can see that, right? So the credit card information will be replaced with X's, and only somewhere you will find the digits, correct? So identifying that this is a credit card information, this is sensitive information, is first part of the data security and privacy. And then replacing them with X's or then removing that particular data from the analysis is the privacy protection part. So this kind of work is actually done by these tools that are present in the cloud offerings. And finally, the scalability and the performance optimization. So this is one of the problem that a data engineer will always face. So while starting, say you are having only 10 GB of data, but in the next 6 months or 1 year, if your product is a hit or if your service is most in demand, then the data might move from 10 GB to 1 TB or 1 petabyte. So as the data size scales, how can you ensure that your data pipeline is still scalable and still it is performance optimized, so that your app or your website or your service doesn't go down and you meet the client expectation? So for that, the data will be ever growing. So your data pipeline should be able to handle that increase in the data. So for that, you have to build a data pipeline that is scalable, which will increase, which will be able to handle the increase in the volume of the data that it receives, and then increasing complexities where you are trying to add more kind of features or more transformations in the data, and then evolving business requirements. So every 6 months, the business requirement can change. So you should be able to re-architect or change your data pipeline without affecting the performance of the user. So some of the techniques that are generally followed for scalability and performance optimization is vertical and horizontal scaling, where you try to increase the RAM and the CPU in vertical scaling, and then you will try to add more hardware in horizontal scaling, that is add more systems or nodes to your processing unit. Data partitioning and sharding. So instead of handling huge amount of data in a single shot, you divide them into partitions and you process them in the form of mini batches. Data caching, so that the frequently used data, you will cache it using the in-memory databases so that the performance is not compromised. Employ data compression and storage optimization techniques so that as the data size increases, the cost of your data lake and data warehouse also should not increase exponentially. Employ distributed processing, mainly with the Spark, because handling terabytes of data cannot be done on a single machine. So we distribute the data across multiple machines where all the machines perform same kind of transformation, so that in parallel you will be able to handle huge amount of data. And use automation and infrastructure as a code, where the example is to make use of Terraform. So with the increase in the demand, you will automatically provision the number of CPUs and the RAM that are required. So you can automatically increase and decrease by looking at the demand that is there. So that kind of an automation can be performed using the Terraform. And finally, monitor the services and then fine tune for performance. For example, if you're having a SQL query which is taking a lot of time on your database, check for the way you have constructed the SQL query and then fine tune them. So this is how you perform scalability and performance optimization. And coming to the data engineering career opportunities. So if you are well equipped with the tools and the technologies that we have previously discussed across the webinar, you can be able to apply for jobs like data engineer, data architect, data scientist, machine learning engineer, big data engineer, cloud data engineer, data analyst, business intelligent analyst, data visualization specialist. And apart from this, you also have a technical pre-sales specialist. Okay. So these are all the career opportunities that you will be having once you master the tools and techniques that are required to design, build, and implement the data pipelines. And once you learn this particular tools and technologies required for a data engineer, what are the organizations that you can target? You can target any organization that is on e-commerce and the retail space, that such as Flipkart, your Walmart, your Amazon. Any of the e-commerce store or the retail space will definitely require data engineers. So any organization or a company that is in this particular domain, you can target that, because they will be using the data pipeline to understand the customer behavior, optimize their supply chain management, and then also personalize the marketing efforts. Next is the healthcare domain. So in the healthcare, where you have many huge hospital chains that are there, right, where the data is stored in a centralized place, and nowadays they are making use of the machine learning models to diagnose the diseases, correct? So all these kind of healthcare related organization or the labs that are there who collect your blood samples and then give you the reports, right? So all these kind of organizations or companies will require data engineers so that they can process their health records, monitor their medical devices or the wearables that are there, and then give insights to users. And telecommunications, so any organization that deals with managing your network, right, or constructing your base station, managing your base station, correct? So all these kind of organization will always require data engineers so that they can optimize the networks that are there and then perform customer analytics and also collect real-time data from the base stations or from the mobile devices and use them for further analysis. Next is the financial domain. So financial domain is the one out of the recent past has the highest demand. So in the financial institutions where you have a lot of data that is coming mostly in the structured format will require a lot of data engineers as well. And finally, the manufacturing industry. So now the quality monitoring or many of the manufacturing products monitoring is being automated. So you'll require a data manager who will be managing their production pipelines, monitoring their sensors and machineries that are present. So these are the domains where you can find the career opportunities for data engineering. And finally, how can you become a data engineer? So for a data engineer, the primary thing is that you need to be proficient in at least 1 or 2 programming languages, such as Python or SQL, and build your database skills. Try to work with different SQL databases, NoSQL databases, you have columnar databases, you have in-memory databases, and so on, right? Try to learn at least one database in each of the particular category. And master the data processing frameworks. So for data processing, we have discussed the Apache Spark, we have discussed Apache Beam and the cloud services, right? Data prep, so on. So all these particular, at least you should have a couple of frameworks in your portfolio that you are aware of. And finally, look at how you can architect that data pipeline, not only using the open source tools that are there, but also using the cloud computing skills. And then get yourself certified on a couple of the databases or the data processing frameworks that are there, such as Databricks, or you can also look at the cloud certifications. And then practice some of the data processing projects and put it on your GitHub or in your portfolio, so that this will help you crack the interviews or to become a data engineer. So with this, we conclude this particular webinar. So in this particular webinar, we have given you only a comprehensive overview of what is data engineering, what are the tools and the skills that would be required to get a job in the field of data engineering. Okay. So I hope this particular session would have helped you or get insights in becoming a data engineer or exploring careers in the field of data engineering. So thank you everyone for attending this particular webinar. So now we'll keep the session open for Q&A. If you have any queries or concerns, I will try to answer to the best of my knowledge. Thank you.